Hi, as promised, so this is my video number 27. Here's my video number 27. I will give a example for the Fourier transform and inverse Fourier transform. Okay, so for the first example, so let's consider this problem. We find the Fourier transform for the function given as minus x, yeah, hence using the inversion deduce that integrate 0 to infinity dx 1 plus x squared, this is equal pi over 2, and integrate 0 to infinity x sine xt over 1x squared dx, this is equal to pi e minus t minus over 2 for t positive. Okay, so first we'll try to find the Fourier transform for that function. Solution. So our fx is given as e minus x. Yeah. So Fourier transform of fx s, this is equal to 1 over square root 2 pi definition minus infinity to infinity, so we have fx e minus I sx dx. Okay, so this will give us 1 over 2 pi. We just substitute the function there, so e minus x e minus sx dx. Right, and here we need to be careful with that. Yeah, we use the modulus, so if you combine those, we have that minus infinity to infinity e minus x minus I sx dx. Now for minus x minus I sx, this is equal to minus t minus I x so this should be minus x here, minus x, yeah, t x for t for x positive, and we have x minus I xs for t negative. Okay, so therefore I can write those integral becomes one over 2 pi, so 2 pi integrate from minus infinity to infinity for for x less than 0, so we have e x 1 minus is, right, dx plus integrate 0 to infinity e minus infinity to 0 here, minus x 1 plus is dx, right? So this is not difficult for you to evaluate. Yeah? You can it's not difficult to evaluate these things, so I just give you the result, so that we have 1 over e, and you take the limit, so you have 2 over square root 2 over pi 1 over 1 plus x squared. Of course, you can write on the left side the constant in front as square root of 2 over pi 1 over 1 plus x squared. You can do that. Okay, now we use the inversion of Fourier transform. Yeah. To answer the next question, yeah, using the inversion, we deduce all those things. Now, for the inverse Fourier transform, we have fx is 1 over square root pi minus infinity to infinity, so we have fs e is x ds. So I think this should be s here. S squared. Now our fs is our fs we obtained just now that this is 2 over pi 1 over 1 plus s squared. Yeah, and remember that our fx is minus magnitude of x. Okay, so if you substitute there, so we have therefore fx is equal to 1 over square root of 2 pi. We use the definition of inverse Fourier transform. This is minus infinity to infinity. Fs is that square root 2 over pi 1 over 1 plus s squared eisx ds. Okay, so fx is that, so on the left side we have that. Remember that we want to deduce this, yeah, integrate 0 to infinity, all those things. So that equal to this equal to, so that we have square root cancel out, so we have 1 over pi minus infinity to infinity. This give you eisx over 1 plus s squared ds, right? And this you can split into from minus infinity to, you can split those things from minus infinity to 0, and that you have minus I as x 1 plus s squared ds plus integrate 0 to infinity eisx 1 plus s squared ds. Okay, so if you use the expansion of e to the I theta, so we have e to the I theta, this is cos theta plus I sin theta. So if you use this, so we have this one is cos sx minus I sine xx, and this one cos sx plus is sine xx. So the imaginary part cancel out. What left, we have twice the real parts. So that will give you, so those will give you 2 over pi integrate 0 to infinity cos sx over 1 plus s squared ds. So if you consider for x is 0, yeah, this is obvious. For x equal to 0, remember that the question is we want to deduce, yeah, there's the question we want to deduce those things. So if we take that equal to 0, x equal to 0, x equal to 0, so what we have here is cos, this is 1 over s squared ds. So s is just a dummy variable or integral variable, so we can just assume with that. Okay, so what we have from there is if we take x is equal to 0, then on the right side, on the left side we got 1, on the right side we have 2 pi 0 infinity 1 over 1 plus s squared ds. So we arrive to our result. So we have, so therefore we have 0 to infinity 1 over 1 plus s squared ds. This is pi over 2. Now for the second parts of our deduction, for the second parts, this is not difficult to show. All right, from this point here, okay, I can differentiate that will give you s negative s sine of this thing. And then if you differentiate both sides from negative and positive, yeah, differentiate, this is the first part, differentiate with respect to x, so that will give you e negative. If you consider x positive, okay, then we have x, then we have those things, negative 2 over pi integrate s sine sx over 1 plus s squared ds. So therefore we have from there negative cancel out, so we have integrate, this is from 0 to infinity, so integrate 0 to infinity s sine sx over 1 plus s squared ds. This is pi over 2e minus x, as required by question. That. Okay, so here should be x here, yeah? Here should be x for x positive, all right. So that's the our first example. Okay, I'll give you another example, second example, in the next video. For now I stop here.